have the integral of e to the x times cosine of x dx. Right away I see I can't use u substitution, so I think integration by parts. So here I set up my table, and right away I separate it into two parts, e to the x and cosine of x. So antiderivative of e to the x is just e to the x, e to the x. And we're going to have cosine of x. The derivative of that is sine of x. And then the derivative of that is negative cosine of x. And then e to the x one more time. So here's our integration by parts table. So I set it up. Integral e to x cosine of x dx is equal to cosine of x times e to the x positive sine of x times e to the x times the integral of e to the x cosine of x. So I write it down, e to the x times cosine of x plus e to the x times a positive sine of x minus the integral of cosine of x times e to the x dx. So looking at this, I see immediately that I have a cosine of x e to the x dx here, and a cosine of x e to the x d here. So I'm going to add one on both sides, or subtract it on this side and add it to this side. So I'll have 2 integral e to the x cosine x dx is equal to e to the x cosine of x plus e to the x sine of x plus c, constant. Now I'll divide by 2. The integral of e to the x cosine of x dx equals e to the x cosine of x plus e to the x sine of x divided by 2 plus c, which will be my final answer. Actually, I can factor out that e to the x. So the integral of e to the x cosine of x dx is equal to e to the x cosine of x plus sine of x divided by 2 plus c. It's the final answer.